All right, everyone, let us begin. Can we just have a quick show of hands? Is there anybody who is new today? So if you're new, just sort of not raise your hand, give us a thumbs up in the chat. I'd love to get a sense of how many of you are new. And then, welcome, Christine. It is great to have you with us. I'm sure today will feel a bit odd at first because you're getting used to the environment. But if you're unsure, Miss Anya, who is the other teacher helping me today, she'll be there to assist you and guide you. And your name is Faith. Okay. Well, Faith, it is good to have you with us. So is anybody going to do the first Maths 24? Is anybody going to steal my thunder? Everybody got the answer. How do we get to 24 using these four numbers? I'm about to pull the trigger, guys. The glory is there for you to claim for yourself. Okay. Anyone? Okay, so the first one is actually sneaky easy. It's just 7 plus 7 plus 7 plus 3. And that gets you to 24. Okay, now that was the first one. Can you do the second one? Or at least can you get close to 24? I typed too slow. Mark, did you miss out on the glory? Well, who can get close to 24? You don't have to get 24. What can we do in the second one? How can we combine the numbers to get 24? I'll give you a hint. If you start with 8 minus 5, that might help you. One of the things you might pick up from Maths 24 is that knowing the factors of 24 is a very helpful thing. So what are the factors of 24? That also might be a useful thing to think about. So if 8 minus 5 is 3, okay, then the way to do this one is going to be, well, I've used up the 8 and I've used up the 5. Now, if only there was a way I could get 8 from 8 and 1, and then I realized, oh, there is. 8 divided by 1 is 8. And now I just go 3 times 8 is 24. Okay, and this is a wonderful exercise for us just to kind of warm up every lesson. And I really do encourage you guys to give it a go. But we are moving on. So admin announcements for today. At the end of today's lesson, there will be a fun quiz that Miss Anya will put in the chat. And when you go off to do that quiz, you don't have to come back to class. Class will finish when you literally go off and take the quiz. And in order to take the quiz, you need to be logged into the Watobe website on an account or profile that you've previously created. And then the other thing is if you are at the end of your 2-week free trial, then your parents will be receiving a message from Watobe saying, look, I hope you've enjoyed it. In order to continue with Watobe, you will need to make a payment. The payment is 75 Rand a week or 300 Rand a month, I think is the way they bill it. And so it's important that if you do enjoy these lessons, you let them know. Otherwise, they're going to think it's spam and, that sort of, won't be helpful. The other thing we want to encourage you to do is to tell your friends, because we know that there are many students who would love some extra maths help. And we think this is a great way to do it. It's very affordable and engaging. And so it's important that you do tell your friends about Watobe because they just may not know about it and how easy it is to just jump on a Zoom with us. Okay, Miss Anya, is there anything from you before I start the actual lesson? I think I've done my admin sort of announcements.
Yeah, I just want my side again. My video is going to be off for most of the lesson because of my computer. Excuse my injuries in the background. And yeah, please just remember to use the chat. That is why I'm here, especially for the newbies. I'm very much active in the chat. I can help there as well. Right, back to you, sir.
In fact, I think we need to get over some chat stream anxiety. So I want every single person who's on the call now to give us a thumbs up or how's it going in the chat, just so I know that you know how to use the chat. I just want to make sure. So I want to see you light up the chat now, please, guys. Please, I want to see it all. It's all good in the hood. Okay, so you know how to use it. That's great. I need to see a few more hands up and things like that. Okay, looks like you all have the ability to use the chat should you need to. Remember that as we're doing this, one of the benefits of being online is that unlike the normal classroom, we can have two streams going. So, I'm answering and doing things, but Miss Anya is also a maths teacher and she's answering the chat. And so don't be afraid to use that in a way that helps your learning. Okay, we really want to encourage that. Okay, so let's talk about what's been going on lately in this unit. This unit is a unit on circle geometry. And we spent quite a bit of time talking about the vocabulary of circles at the beginning. And then we did a bit of kind of simple exercises. So simple exercises around circles. And then we did some recap of grade 9 and 10 geometry, which focused on straight lines and triangles and using those. And then in the last lesson, we more and more were focusing on what I'm going to call theorems or facts about circles that involve the center of the circle. So basically, up until grade 11, most students know about a thing called a circle. They know about the diameter and they may know about the radius, but they don't really know too much more. They might know about this formula, circumference is diameter times pi, but they haven't really thought about a lot of the detail that's hidden in the circle. And so some of the things that we've been discussing is that in a circle, excuse my approximate circle, if you take 2 points on the circumference, let's call them A and B, if you are connected with a curved line, that's called an arc. And if that arc subtends, that's our fancy word, or makes an angle at the center, and then if that same arc makes an angle at the circumference, there is a relationship between these two. They're not the same, but they're a very particular relationship. And we call this one at the top the angle at the circumference, or the inscribed angle. And then the one down here, we call that the angle at the center. And look at me writing out the word angle. Who does that? In mathematics, we have a special symbol for angle. Can anybody tell me what the relationship is between the angle at the center and the angle in the circumference? I'd love to see what you can remember. It's half. Okay, so the angle at the circumference is half the angle at the center. So an example would be if this was 60, that would have to be 30. And the other thing that we kind of explored a little bit was there are different types of shapes that we can get. So sometimes, okay, and also we can do this with chords. Instead of going along the curved line, we can connect these two. Then that line is called a chord, and the shape doesn't have to be as nice and neat as this. We can also have something like that. And I mean, that starts to look pretty funky, like a hippie type, or like a Woodstock symbol or something. And so in this scenario, what we have is we have the angle at the center, which is here, and the angle at the circumference, which is here, and they're being subtended by this chord here. Okay, so that's a little bit of, if you've been away, so if you're brand new today, that's going to feel like, oh my goodness, what's going on here? But I just want to emphasize we're going to focus on a few more facts about circles and facts about that relate to the center of a circle. And then we're even going to talk about something new called a cyclic quadrilateral, if time allows today. Okay. So let us go to carrying on from where we were in the last lesson, and let me go here. So another fact that we need to talk about and learn about today is something called an angle in a semicircle. Now, what is a semicircle? Well, a semicircle is half a circle. So if you imagine a diameter cutting a circle in half, then what you have is you have a semicircle. However, if you have a diameter and it's making an angle at the circumference, it will always be 90. Now, this is a bit weird, but how do you think this is connected to the previous thing I showed you? Who can see the connection between this fact and the previous theorem that I just did? Because it's quite an important connection, and this fact will stick in your head so much more if you can see the connection between the previous fact and this one. So this is an angle at the circumference. We can see it's at the circumference because we're this bit of, oh, I can even move this. Oh, wait, am I telling fibs here? Oh, sorry, if I move this, sorry. If I move this angle, look at this. Look at how that doesn't matter where that point is, as long as that angle is at the circumference, it's going to be 90. Now, if I move this off, can you see how it's no longer a diameter? So the moment it leaves, the moment it doesn't go through the center, it doesn't work anymore. But the moment that it is going through the diameter, then this thing can be anywhere. Now, that's helpful to know. It's a good fact. But what's the connection to the last lesson? Let's think about this. Oh, let's make a bit more space, actually. Anyone in the chat, even if you get it wrong, I just want to see what's the connection between the two. Well, think about your 2 points. The chord, it's half. Yes, Kiribona, it is. Think about this. If you make an angle at the center, isn't that angle going to be 180 degrees? And now, if you use those same 2 points on the chord, and they make an angle at the circumference, the theorem that we were talking about before says that this has to be half of that, so it has to be 90. And so that's why whenever we know that this is a diameter, excuse all the, I have a few too many colors going on. The moment we know that this is going through the center, we know that the angle that it makes at the circumference will be 90 degrees. Boom. Yep. Mind blown. Mic drop. So I want to practice this idea and see if we can use this idea to help us solve problems. So I'm going to give you these 2 questions, and I want you to do the following. When you've worked out what A and B is, so for one, I want you to put the answer for A, 1A, and the answer for 1B. What is the value that you can work out? And then for the second one, we'll call this, oh, this is actually confusing. Let me make this, this is 1A. Just say, 1A, and then give us answers A and B, and then say 1B, and give us answers A, B, and C. I want to see if you guys can figure this out, because I want to give you, how much time I'm going to give you? I'm going to give you 3 minutes, so until 18:17, and all you have to do is just think about how do you use the facts that you learned about circles to help you figure out what this angle is, what this angle is, and in this case, what's this angle, what's this one, what's that one. See what you can figure out. And notice how you're living in circle land now. And in circle land, there's certain things that we know always are true. And while you do that, I'm getting some water because I need to stay hydrated. Mbali, let's see what you said. So Mbali definitely noticed that A was 90, which I totally agree. That's what I was talking about. And then I suspect he used the idea that there's a triangle hiding inside the circle, and we know that all triangles add up to 180. And so using that fact about triangles, he worked out what B was. Notice how he used his knowledge of circles or triangles at the same time. And I think Mark did the same, Tyrese did the same. Zianda also seems to be on the right track. So we know that this over here is 90. Let me quickly get this. Pen, blue, make it smaller. This one is going to be 90 because I'll give you the name of this fact later, but for now we're just knowing that's 90. And then to get this one, we go 180 minus 90 minus 55, and we get 35. So what's the answer going to be in B? B is a little bit trickier. So David, focus on what I just spoke about. This is this a diameter? It's a diameter. And then ask yourself, oh, based on the previous lesson, or based on the previous example, what does this angle have to be? And since this is going to be 180, this angle, this has to be 90 there. Yeah, so Susanna, would A's reason be semicircle? And the reason is, it's called an angle. The official reason is angle in a semicircle. But I'll go over reasons explicitly in a future lesson. For today, I want to really focus on just knowing the facts, and then I will be explicit about the reasons. I find it's good to separate the two at the early beginnings of circle geometry. Okay, so what about B? What's going on in B? B is a bit trickier. Which one do we know for sure? Well, I know that this is a diameter, so maybe that can help me. I think I know that A is 90 for sure. Because A is the angle at the circumference where the diameter is subtending this angle A at the circumference. But now if I know this is 90, then can't we work out, I'll make it even bigger. I know that it really helps the students on mobile phones if I do this. If I know that A is 90, couldn't I then work out what C is? And I think C is just going to be 180 minus 90 minus 62, which is 8 to get to 70, 20, 8 degrees. Okay, now, okay, there's actually something sneaky hiding in getting B. B could be quite difficult unless I haven't taught you about this, and so I'm actually going to have to probably. How did you get Sibosiso? How did you get B? Have I missed something? I can only see doing it with cyclic quads. So I know. Oh, I know what C is. I know what that is. I think I might have to use cyclic quads for this, but let's see. So C is 28. And then I need a way to compare. I know what these two are together. They are 60, but that doesn't help me with that. And yeah, I think I'm going to have to use something called cyclic quads. So everyone's saying B is 58. Okay, so this is a little bit ahead, but let me use it as a teachable moment. If you look at this question, C and A are a piece of cake, but there is another fact about circles that I'm going to use that I haven't spoken to you about yet, but I'm going to highlight it so you can see. This is a four-sided shape inside the circle. Now, what is a four-sided shape? A four-sided shape is called a quadrilateral. Okay, so that's a quadrilateral. Now, what's special about this quadrilateral is that this quadrilateral has all its vertices on the circumference of a circle. And so when we have a quadrilateral that has its four vertices on the circumference of a circle, we call that quadrilateral not just any quadrilateral, we call it a cyclic quad. And so this is an example of a cyclic quad, which I will talk about more later in the lesson. But one of the properties of a cyclic quad is that opposite angles in a cyclic quad are supplementary. Now that sounds like a real mouthful. So another way of saying it, an opposite angles in a cyclic quad, when you add them together, they sum to 180. And all I'm going to do is I'm going to use that fact to help me get B. I know that 28 and 32 are 60. Okay? So I know this bit over here at the top is 60, which means that this bit at the bottom has to be together 120 in order to give me 180. But that's not what I was after. I was after the B, and the B is sharing the 120 with the 62 next door. So that 62 is already gobbling up some of the 120. So what do I need to basically add to 62 to get to 120? And the one way of doing it is just saying 120 minus 62, and you would get 58 degrees. So we had to jump ahead. Huh? Yeah.
There's also another, you could have gone at cyclic, but what other learners could have done is they could have used the angle on the right. They would also need to, so top right.
Yes, top right.
No letters. What would the size of that angle be, learners or students?
Oh, you're right. You're right. So there is an easier way to do this now. I see it now.
If you do that, then you can just do sum of angles in a triangle to work out B, and you get to the exact same answer. So I think some learners might have gone that route.
Perfect. You know what, actually, guys, I thought that I didn't have to tell you about cyclic quads yet. And then my brain was like, huh? But actually, it sort of hides in plain sight, because this is a diameter, this angle, that is at the circumference. And so this would be 90. And if I know what that is, and I know what this is, I can just go 180 minus 90 minus 32. And so then I get, that was much faster. And I think a lot of you knew how to do that, but you got a bonus lesson about cyclic quads, which is coming to you soon. Okay. Now, can you do these two, C and D? See if you can find A, B, C, D, E in this one for C, and then try and do it for D as well. See if you can figure out the unknown items. And the only thing I'm going to point out to you is that this is a diameter. It's going through the center. And this is also a diameter. It's going through the center. So ask yourself, which of these things can I get? I need to get A, B, C, E. And in this question, I need to get A. Now you may not do them in different orders. With both of these questions, you have to work out 5 angles. Okay, so first of all, I'm fairly confident that this one, I know what that whole angle over there is. How could I use that to work out what A is? Okay, I'm going to go a little bit quiet for a bit. I'm going to give you 3 minutes by yourself to, well, actually, let's make it 5 minutes, because this takes a bit of thinking. Let's see what you guys can come up with. Okay. Let me turn the lights on in the background as well. Okay, so I do think that if I'm looking at, where's my pen go? Oh, there it is. Let's see. So I could go 90 minus 57, or I could say, what do I need to add to 57 to get to 90? And so A is going to be 33 degrees. So this angle over here is going to be 33 degrees. Now, what else can we work out? Well, wait a minute. These are radii. So this one from the center of a circle must be the same length as that one. How can you use that to help you? That's what I want to ask. And so we spoke about this, I think, in lesson 2 even. If isosceles triangles, or triangles that have two sides equal, the base angles will be equal. So this B is going to be 33 degrees. And then that makes E quite simple because this forms a triangle. And so what E is must just be 180 minus the other ones. So let's keep those answers coming in the chat. I want to see that chat lighting up. Again, my philosophy is this. Even if you get it wrong now, I don't really care because I want to see you participating. I will give you the feedback around the correct answer. But just the act of going through the process helps you retain the right answer more than if you've just been passive. So please don't stop putting those answers in. Keep going, keep participating. So E would be 180 minus 66, and that should be 116 degrees. No, I'm lying. It is 114. My brain had a moment. And then once I know what that is, then I know what D is because these are angles on a straight line, and they add up to 180. And so that would be 6 plus 60. So D is going to be 66. And then what is C going to be? Well, I think C is also this is another isosceles triangle. And so we know that this 57 and this C over here must also be 57. Now, I think I might have gone a little bit fast, but whilst people are working on the second question, give me a thumbs up if the pacing is about right. Give me a thumbs down if I'm going a little bit too fast for you. I just want to get a feel for the group. We are going to take a break after this question. I know it's quite tough, but I just want to get a feel. And again, be honest, guys. You can be completely honest. We want to get a feel for the group, and we will assist as best we can. It helps us when we have like a trail of what's going on with you. Okay. Okay. No, it's good. I can see it seems like we're just about on the right pace, give or take. But again, we will help. Ms. Anya will be helping in the chats, giving suggestions. And so I want everyone to focus on question D now. And then we're going to... Okay. So Mbali has 108 for B. Mbali, I agree, because we know that B, let's actually zoom in on this one so it's nice and big and we don't get distracted by anything else. If we look at finding B, we know that together B and 72 must add up to 180. And so that's why we know that B would be 108 degrees. Now, does that help us figure out the other things? Like A. And this is where you need to be sneaky because, first of all, let's actually, what are the things we know? Actually, maybe I should slow down. This is a diameter. So we know that could be useful. And also we know that this, oh, that's way too big. Let's go like that. Go to a red color. We know that this line over here, well, it's still too big. I'll make it disappear now. Those are radii. So how can we use the fact of radii to help us solve this problem? And I think that that can help us work out what A is, potentially. Okay, I see some answers coming through. I'll give you feedback in a moment, but just keep them coming. Okay, yes, I definitely agree, David. Oh, wait, no, let me see if E, I have to check. I'm not sure it's 108. Okay, I'm going to try and get A. Now, I know that A is one of two angles in this triangle. And what I know is that these two sides are equal. It's isosceles. So what I'm going to say to find A is I'm going to go 180, take away 108. What do I get? I think I'm left with 72. But now those 72 have to be spread between here and here. And so I think that I need to divide them equally. And so 72 divided by 2 is 36. And so for me, A would be 36 degrees. Okay. Now, I can't quite see. Let me just get rid of this. So which one is E? Which one is D? I know that this E and D together would be 90. And so the reason I know E and D together is 90 is because of this angle in a semicircle theorem, which I've kind of been talking about the whole lesson, that E and D together are 90, but we know that E by itself must be 36. And the reason is because it's the matching base angle in the isosceles. Now, how do we use the fact that we know the whole thing is 90? We know E is 36. Can't we work out what D is? Okay. So if you look at that, I think I should just go, well, take 90, take away 36. And what am I left with? And I agree. I see the Moyle family. I agree. It is, what's 36 plus what gets me to 90? So 4 to get to 40. I think it's going to be 54 for D. Unless I'm having a moment. No, that's all good. So that's 54. And then the last thing we need to worry about is what's poor old C. And we know there's a 36. We know there's a 90. Maybe I should even highlight these angles. So there's my 36. Here's my 90. The only one that's left is this one. And so that together has to add up to 180. So maybe we should even add the 36 and the 90 together first. We get 126. So then I have to add another something to get to 180 because it's a triangle. So what do I need to add? I need to add 4 to get to 30, and then that's going to be 54. And so C is going to be 54 degrees. Yeah. I mean, that was quite a tricky question, guys. Like, notice how you're using the radius, you're using the angle in a semicircle, you are using isosceles triangles, the sum of angles in a triangle. So it's pretty advanced stuff. So well done for you. All right, I think what we need is a little bit of a break. So let us all stand up. I will adjust my webcam so that you can see me. And with doing maths this late in the day, we really need to be mindful of our brains taking a bit of a pounding. And so what I want you to do is I'm going to lead you through a little brain break. Okay, share, stop share. Okay, that's me. Oh, there we go. Okay, so what I'm going to do is I'm going to ask you to take your right hand. Actually, let me move this camera a little bit down. Take your right hand and put it on your nose. Take your left hand and put it on your right ear. And then I want you to think about, how do I switch this so that I'm on the opposite side? You're going to take your left hand to your nose, and your ear goes to the opposite. And I want to see, can you switch? I've done this before with you, I think. How quickly can you do this? Because your brain has to make these connections. And it's a really good exercise, I'm told, for just getting your brain to forget about maths and just focus on something else. So if you're feeling very brave and you've got this, turn on your video so we can see how fast you can do it and see if you can do it faster than me. I don't think so, because I've practiced this a lot. But let's see some brave students who are willing to show us what you can do. How's your midline crossing going? And then let me share back to this, back to the maths. Yeah. Are any students amazing you, Miss Anya? With their dexterity?
Yeah,
is it impressive?
it's quite fun. Can you hear me?
I can hear you, yes.
Okay, no, great. No, I'm saying it's quite fun. Actually, I wanted to show like another trick as well, but I was a bit late there. Also, like involves where you have to like cross over and stuff. It's like a thing I saw ironically on TikTok, which was actually like quite fun. But yeah, anyways, back to you, sir.
Well, absolutely. So please save them for the next lesson, because we're always looking for interesting things just to help our brains relax and unwind a little bit between the lessons. Okay, so I hope you enjoyed that. What I want to do now is I want to talk about, I'm actually going to, okay, I haven't showed you all the facts on this, but what I'm going to do is I'm going to, what am I going to do today? Okay, I will come back. When we talk about circles, let me talk about information you need to know, and then let me talk about what we're going to practice for the rest of today. So when we talk about circles, okay, there's actually three main areas that you need to know facts about circles. We'll call them theorems, but theorems really are just facts that are proven. And so what you've been learning about recently, let me just make my pen a little bit thicker, is you are learning about facts that have to do with the center of the circle. Okay, so you've been learning a lot about circles and facts that relate to the center of a circle, but you also need to learn about facts that relate to something called a cyclic quad, which I'm going to briefly discuss now with you and just do a couple of basic exercises. Now, I haven't finished all the facts about circles in the center, but I feel like today it will do us well to go into something a bit different. Then the last bunch of facts that we need to get used to are facts about circles and something called tangents. So what are tangents? What are the most important bits about circles and tangents that we need to know? And just to remind you, what is a tangent? If you have a circle and you have a line come past it and it just touches that circle in one place, the special word for that is called a tangent. A cyclic quad is a quadrilateral where all the vertices are on the circumference of a circle. And so, for example, this would be one type of cyclic quad. However, cyclic quads can look quite weird. Like you could have, ones that are a bit squeezed up in one corner. And so just be aware of that. So I'm actually going to spend the last bit of today on our learning on cyclic quads. And I want to show you some basics. And then from there, we'll do some exercises, and then we'll call it, we don't want too much new information on one day. So let me go try something new. Okay, and let me get rid of the notes. Okay, here we go. We have in front of us a cyclic quad, and the reason it's a cyclic quad is A, B, C, and D are all on the circumference. Notice if I move these around, we can change the numbers, but what's interesting is if I move this one around, the red angles are not changing. It's only the purple ones that are changing, which is interesting. If I move this one over here, then the red ones are moving. Okay, whatever. It's kind of random, but it's interesting. Now, what you'll notice is In a cyclic quad, there's a particular property. The opposite angles are not equal to each other. Okay, they're not equal. 82.1, 97.9, they're not equal, these ones. But they do seem to be in some sort of relationship. We know that all quadrilaterals, something else, this is from grade 10, all quadrilaterals will add up to 360, right? So the moment you have a four-sided figure, so all quads will add up to 360. And the reason is a quadrilateral is really just two, let me see if I can get this right. Any quadrilateral four-sided shape is really just two triangles knitted together. And we know each triangle adds up to 180. So two triangles together give us 360. So that's old geometry from grade 9 and grade 10. What I'm wanting to look at now is what is special about a quadrilateral that has a circle that goes through it. And what I want to show you is that opposite angles in a cyclic quad add up to 180. So opposite angles, the fancy way of writing it is like this. Opposite angles in a cyclic quad are supplementary. So op is an abbreviation, angles is plural, many angles, supplementary. In a cyclic quad, and I'll show you this, watch as the numbers change. Does the total actually change? Nope, does not change. The angles might change, but the sum together of opposite angles in a cyclic quad does not change. And so that's an important new idea that I just want to, that we need to know to use in our questions. So let us do question 1 and 2 together. Make them very big. Can you guys do for me question 1 and 2? Try and get them even bigger. I don't think I can make them much bigger. Okay. Can you please try and do 1 and 2 for me? Question 1, and then give me A equals, B equals, and then question 2, C equals, D equals, and put that in the chat. So if you physically draw circles, it's quite interesting to see this fact about circles. But for the purposes of today, all we're doing is we're familiarizing our brains with these new facts about circles. And they will allow us to solve problems about circles very efficiently once we've absorbed them. Okay. I can't see the chat stream at the moment, Anya. For some reason, I've managed to bury it somewhere. Are the answers coming through, or how are we doing on the answers there?
No, we're doing okay. Just one student asked, they're a bit confused of how to get A. So I'm still going to answer on your behalf, so if you don't mind. So if you see the opposite angle of A is 86 degrees. So Sir just taught us now that the opposite angles in a cyclic quad are supplementary. In other words, they must always add up to 180. So if the one opposite angle is 86, I can then say, right, 180 minus 86. And my brain is a bit off today, but I think it's 94.
Yeah. So we go 86 plus A must add up to 180. Or another way of saying that is to say, well, what do I need to add to 86 to get 180? Or you could just say 180 minus 86, which does indeed give you 94. And so this would be 94. Now we're using this new fact about circles that we're just busy absorbing. I haven't shown you what proofs yet. I haven't shown you why that's true. You kind of are accepting, look, I'm a math teacher, I should have learned this. So for now, all I'm doing is asking you to familiarize yourself with it. However, there is actually a proof as to why this is true, and that's a very interesting idea. But for today, the goal is just to get used to it. We're just kind of introducing ourselves to these ideas. So using the same idea for B, well, we know that in order to get B plus 105 must equal 180 if this new idea that I've told you is true. And so you ask yourself, well, what do you add to 105 to get 180? Well, then B would be 75. Okay, so that would be 75. Now, for those who are feeling comfortable, I'm actually going to ask you to try and do question 3 and can I squeeze them in? Question 3 and question 4. See if you can figure out what question 3 and 4 is. And I think we're going to end it at that point after those questions. So these will be the last questions for the day. I think that if we try, my experience with students, having taught this many times, is if you try and do too much on any one day, they get a bit confused about like all the different pieces and how they fit together. So the main goal today was we spoke more about an angle in a semicircle and some ideas around the center of a circle. And then this new thing about cyclic quads. What is a cyclic quad and what are some of the properties of cyclic quads that we can use when we're figuring things out? That's really the summary of the lesson. Okay, so I'm going to give you 4 minutes or so just to try and work out what C and D are. And you might have to use some other ideas as well to do that.
And then just while you guys are doing that, I know you guys are focusing super hard, but please don't hop off too early off this lesson, because remember, I'm going to share the link to tonight's quiz in the chat in a bit. So please don't hop off too soon.
Yeah, so the lesson will formally end after these questions when we kind of give you the quiz link. The quiz won't take you too long. It's just also just repetition of the same ideas, but we do want you to complete that for your own learning and also to help us get a sense of what you're absorbing, what's working, what isn't. And so, yeah, the lesson will finish with doing that formative quiz. Okay, so for number 2, I think that we can work out that 4 gets us to 100, so this must be 84. Then we've got a little bit of a problem, but I'm going to say I know that angles on a straight line add up to 180, in which case this must be 79. And then I know that together these must add up to 180, so this must be 101. Now, not all of you would have got that, but I just want to point something out that's quite interesting, is that the exterior angle of the cyclic quad, that's the fancy word for it. So maybe I should get this angle here is outside the cyclic quad, and just like a triangle can have an exterior angle, a cyclic quad can also have an exterior angle. And in this case, the exterior angles seem to have a relationship with this one down here. I just want to point that out for now. In the third one, I think the same idea could be used again, where you could say, look, 92, we know this angle must add up to 180. So what can we do? Well, it's 8 to get to 100. So this must be 88. And how do we use this 88 to then figure out this? I'll give you a bit more time. And also, what about this lonely Y down here? How do we figure that out? And again, Anya, if you could just pick up if there are any major issues in the chat. My chat is still buried, but I think students will find this challenging, but they have enough skills to get going with it.
No, everything's still good on this side. They're still managing quite well. I must say, I'm actually quite impressed with tonight's lesson. Like the kids are very quick and all.
Things are getting quite, also the complexity of what we're doing is growing each lesson. And I'm glad to see the students kind of, they're taking what they've learned before and bringing it forward, which is obviously, you know, the plan always, but it's lovely to see. Okay, now I think for X, 88 plus X they must add up to 180. They're supplementary, right? So 88 plus X must be 180. So what is X going to be? Well, X is just going to be 180 minus 88, which is going to make this 92. Now, how do I get this Y down here? Well, there's a couple of different ways you could do it. The one way to do it, I suppose, is to say, well, it's a quadrilateral, so 360 minus all these angles is one way to do it. Or you can say, well, if this is 116, this must be 4, this must be 64, because together those two would add up to 180. So that is one way of doing it. And then once you know that that's 64, this must be 116, because these also have to add up to 180. Apologies if I'm going a little bit fast now. I know I am speeding up a little bit. Now, what is going on in this last question? You know what? I think I'm probably going to save this question for the next lesson. I'll begin the next lesson with it. I'm just going to give you some tips about how I would approach it. The first thing is it a cyclic quad? It does look to be a cyclic quad because its 4 sides are here. So we know it's a cyclic quad. What we don't know is how to work out anything else at the moment, except the properties of a quad. Okay, I'm going to start the next lesson around this. This is a little bit too complex for where we are now. So, Ms. Anya, if I can ask you please to put the link to the quiz in the chat. What I'm going to do is for students who don't feel comfortable, we're going to stay online and we're going to discuss any questions you have. But for those students who feel good and are feeling comfortable, I want to encourage you to go and do the quiz now. Do it to the best of your ability, and then we will continue on Monday next week. It's been lovely teaching you today. Don't feel worried if today's lesson was the most challenging one you've done. It definitely was. We're starting to put multiple ideas together at once. And so if we need to recap things, we definitely will. But just go off and do the quiz now and do the best that you can. And so you could just give me any questions or comments as needed.
Yeah, just one thing. I'm trying to sort it out in the chat. So I'm still going to speak. I think it's easier. This is more directed at Sarah and Amara and anyone else that might be quite new. In other words, you started or joined us in the last week or two. So for grade 11, Wednesdays are quiz days. So how it works is normally Sir first does his lesson like he did now. And then at the end of the lesson, we do our quiz, because sometimes, not always, but sometimes there might be content in this lesson that will be in the quiz. So if you found that you're quite new and you did the quiz accidentally beforehand tonight, it's not the end of the world. But just know for future, rather wait until the end. That's all from my side.
Yeah, so it's better if you do wait for the end. But again, I think you can do it a second time if you like. But generally, we want you to take it at the end. That is the main idea. Okay, let's get some questions from the quiz. From the chat stream or from students. And if you could just let me know. I found my chat stream again. Good news.
Yeah, we've got a hand from David. I think David's a bit lost. He's not lacquer with us today. David, you need to get on par. You can do this. We know you can.
Give us a question. Yeah, let's go. Yeah.
So can you
go back to which one? 3 or 4? I lost you there. Okay. I lost you there, David. Okay.
I think David did screenshots. That's probably why.
Ah, okay. Oh, but I just rubbed out everything, so maybe I can just bring it back. By the magic of the internet. Can I bring it back? Oh, I can. Gotta love Control Z. Can we get a clue for question 4? Okay. The clue for question 4 is that all quadrilaterals add up to 360. So all of these angles together is going to add up to 360. So that would be one piece of information that would be helpful. Now that might by itself be enough. The other bit of the other information is that's helpful is this is a cyclic, sorry, opposite angles in a cyclic quad. This and this one always add up to 180. So that might be able to help you because the two green ones are opposite each other. And then the other ones that are opposite each other, and this is where it's a bit weird, are these two. And those pairs always add up to 180. So maybe that could help you there. I think Nizola is onto something there, yeah. All right. So again, let's keep those questions coming. But if you are done for the day, if you feel comfortable, get that quiz done, and then we've done an hour of maths, which is pretty solid, guys, on a Wednesday. I've really enjoyed teaching you today. It feels like we're getting into a better and better rhythm each time we do this, and I think that you're making good progress. But yeah, let's go. If you could hit us with your question. I think the answers are flooding in now, aren't they? 4D, so D. 3D plus D is 180. Yeah, that does sound like we're on the right track. So if you had 3D plus D is 180, that means 4D is 180, which hopefully means we can figure out what D is. All right. Now, what about C? So I see, excuse the pun there. I could have 2C plus C must also equal 180, which means 3C is 180, which means that C should be 60. Yeah. And D should be 45. I think that's right, yeah. Well, I'll talk about this at the beginning of the next lesson, but yeah, that actually went quite well. Are there any other comments or questions, guys, before we... All right. Well, then we're going to say good night. And I hope that you enjoy the quiz. And yeah, well done for working hard. I think that I've said this a couple of times, but the motivation to keep coming, to have your goals, and know that with the last 2 years that we've had where it's been crazy, every student needs to catch up a bit. And so I salute you for your discipline and your sense of drive. And yeah, fun. Yes.
So I missed when you're explaining number 1, 2, 3, and 4. I've been having some issues with the connection, and I don't quite understand what's really happening.
Okay, let's talk about question 1 quickly. So the main idea in question 1 is there is something called a cyclic quad. A cyclic quad is a quadrilateral that has its 4 sides or 4 vertices on the circumference of a circle. So that's step 1. Step 2 is to realize, and this is a fact that we discussed today, is that there are opposite angles in a cyclic quad, and something's quite important or special about them. So when we see these pairs, they are always going to add up to 180. So for example, in 1, we know, let's change the color because red's a little bit too dark. In 1, we know 86 plus A must be 180. Let me also zoom in so that I don't know if I can zoom in anymore. Let's try. My computer is not letting me zoom anymore. Come on, computer. No, that's about it. And so those pairs together add up to 180. And to now ask yourself, well, what do I need to do to get A? I just go 180 minus 86, so 94. And so this is 94 degrees. Together, these two add up to 180. Now, using the same idea, these two have to add up to 180. And if I know this is 105, this would have to be 75. So I'm using the same idea, the same one in the second one. These two together add up to 180. I need 4 to get to 90 to 100. And so this would be 84. So I hope that helps. I will continue with this in the next lesson. Okay. Any other questions or comments? All right. Well then, Anya, I think if you've put the link in the quiz, if all the students had that, I think it's time for us to bring the session to a close. Thank you, Anya, for all your help. And yeah, it was good. And I will see you on, I think we're Friday, we have a meeting. So yeah.
All right. Bye.
I hope.